Ever feel like you're drowning in a sea of development boards? You're not alone. In the next few minutes, we're going to clear all that up. We'll map out the whole landscape from the super simple to the crazy powerful so you can find the perfect brain for your next project. And that really is the big question, isn't it? I mean, it can be totally overwhelming. You've got your Arduinos, your Raspberry Pis, your ESPs, a whole bunch of others. And they might kind of look the same, but trust me, they are fundamentally different tools for very different jobs. So let's break it all down. So here's our game plan. We'll start with finding the right tool for the job. We'll climb what I call the microcontroller ladder. Then we'll make the huge leap over to computers. After that, we'll check out some specialized powerhouses, and finally, nail down the perfect match for your project. Let's get into it. All right, first up, microcontrollers. These are the absolute workhorses of the electronics world. We're going to tackle these like a ladder, starting at the very bottom rung and climbing our way up in power and complexity. And here it is, the board that started a revolution for millions of us, the Arduino Uno. It's a classic for a reason. Now, look, its specs might seem kind of tiny today, a 16 megahertz processor, just 2 kilobytes of RAM, but its superpower is its simplicity. Your code runs bare metal, meaning it's right on the chip. There's no operating system getting in the way, and that means it is deterministic. Whatever you tell it to do, it does it exactly when you tell it to. It's perfect for things like reading a sensor or spinning a motor with super precise timing. Okay, climbing to the next rung, we meet the ESP32, and whoa, the jump is massive. Just look at this. We're going from a board that needs a cable for absolutely everything to one that has Wi-Fi and Bluetooth built right in. And it's not just about losing the wires. This is a huge leap in what's possible, all backed by a processor that's over 15 times faster. And yeah, this is exactly why the ESP32 is the absolute go-to for any Internet of Things project. With a beefy dual-core processor and all that connectivity, it honestly makes the poor old Arduino look like a pocket calculator. If your project needs to talk to the internet in any way, smart home gadgets, remote sensors, this is almost always your board. So we've gone from simple to connected. The final rung on our microcontroller ladder? This is where we go pro. The STM32 family of chips is what really separates the hobbyists from the professional embedded engineers, the people building products that actually get manufactured and sold. So here's the deal with an STM32. You trade ease of use for industrial-grade power. You give up that plug-and-play simplicity of the Arduino, but what you get back is insane microsecond-level precision and rock-solid reliability. That's exactly why these are the chips trusted inside things like high-performance drones, critical medical equipment, and factory robots. This is the board you learn when you want to build real-world commercial products. Okay, hang on, because we're about to make a fundamental shift here. We are leaving the world of single-task microcontrollers behind, and we are jumping headfirst into the world of versatile, single-board computers. This is a completely different ballgame. And this right here, this is the great divide. A microcontroller like that Arduino or ESP32, it just runs one program over and over in a loop. That's it. A single-board computer, though, runs a full-blown operating system, usually Linux. It can multitask, it can manage files, it connects to networks. Basically, it acts just like your desktop computer. And the undisputed king of this whole category is, of course, the Raspberry Pi. The most important thing to remember is right there in the description. It is not just a board with some pins on it, it is a tiny, hackable Linux computer. To really get your head around how big of a leap this is, let's just talk about memory. So remember the ESP32, our powerful connected microcontroller? It has 520 kilobytes of RAM. Got that number? 520K. The Raspberry Pi 4, on the other hand, can have up to 8 gigabytes of RAM. Yeah, let that sink in. Over 15,000 times more memory. That single gap explains everything. It's why a Pi can run a web server, a database, and a full graphical desktop all at once, while a microcontroller just can't. Now the trade-off? Because it's running a complex OS, the Pi isn't great for that super precise real-time hardware control we talked about earlier. All right, so we've covered the general purpose players. Now, let's look at the specialists. These are boards that have been designed from the ground up to be amazing at very specific, very demanding jobs. And you know what? That's not just some marketing line. The NVIDIA Jetson Nano is built for one thing and one thing only: running artificial intelligence and machine learning models right there on the device without needing to talk to the cloud.
This chart pretty much tells the whole story. A Raspberry Pi really struggles with AI. But the Jetson Nano, with its dedicated 128-core GPU, has all the horsepower you need to do something like real-time object detection straight from a camera feed. If your project involves a camera and a neural network, this is your tool, period.
But what if you need both? What if you need the Linux power of a Pi, but also the real-time hardware control of a microcontroller? Well, say hello to the BeagleBone Black. This thing has a really clever hybrid design. Its main processor runs Linux for all your complex applications, but it also has two tiny, independent microcontrollers right on the same chip. They're called PRUs, or Programmable Real-Time Units. These guys give you that deterministic, nanosecond-level timing control. It's really the best of both worlds for robotics or industrial automation. Finally, let's touch on two boards where the software is really the star of the show. Over on the left, you've got the Tesla 2. It's built for web developers who want to control hardware using the JavaScript and Node.js tools they already love. Then on the right, you have the Particle Photon, which is built for businesses. Its real power isn't the board itself, but its integrated cloud platform that lets you securely update thousands of devices in the field, that's over the air, and manage them all from one dashboard. That feature alone can save a startup months of development time. Okay, we've climbed the ladder, we've made the leap to computers, and we've met the specialists. We have covered a lot of ground. So let's bring this all home and figure out how you choose the right tool for your specific job. So let's just boil it all down to a simple guide. If you're just learning the ropes, grab an Arduino. Building any kind of connected IoT device, ESP32. Ready to design a professional commercial product, level up to the STM32. Need a tiny Linux computer for general tasks? Raspberry Pi, no question. For on-device AI, it's got to be the Jetson Nano. If you need both Linux and real-time control, the BeagleBone is your answer. And if you're building a connected product that needs to scale, you should really look at Particle. And that right there is the ultimate takeaway from all of this. It is so tempting to just go out and buy the board with the biggest, fastest specs. But that's not the goal. The best engineers don't use a sledgehammer to crack a nut. They pick the tool that perfectly fits the problem they're trying to solve. So there you have it. You now have a map to the entire landscape. You know the players, you know their strengths, their weaknesses, and the exact jobs they were built for. The only question left is, what amazing problem are you going to solve?